Welcome to another new video of interesting math problem on our channel Math Solutions for You. Please do like, share, comment, and don't forget to subscribe to our channel. If x minus y is equal to mod x minus mod y, which of the following relationships cannot be true? And then we are essentially given the different domains in which the variables x and y could be. For example, the first one is x greater than equal to 0, y greater than equal to 0. The second one, x greater than equal to 0, but y less than 0, and so on. So we have, 4 different domains of x and y, and we have to determine which of these cannot be domains of x and y given the relationship that x minus y is equal to mod x minus mod y. So mod x essentially refers to the modulus of x, or the absolute value function, or the magnitude of the variable x. And its definition is pretty simple, but you have to remember what it is. Right, so mod of x is equal to x if x is greater than equal to 0, meaning if x is 0 or a positive number, then modulus of x is equal to x. But if x is less than 0, then mod x is simply minus x. And this relationship will be similarly defined for mod y, right? So keeping this relationship in mind, we have to basically go through each of these 4 domains that are listed from 1 through 4 and basically see what the relationship of x and y looks like, what this given equation or given relationship looks like for each of those different domains. So we start with this one, x greater than equal to 0, y greater than equal to 0. So that's the first domain given in option 1. And for this, we essentially, the left hand side of the given equation is of course x minus y in all cases, right? But it's the right hand side that changes, and in this case the right hand side is also x minus y. So we have x minus y is equal to x minus y, which is an identity. And an identity, it is true no matter what values of x and y are, provided that they are in that domain. So this is a simple case. So the option 1 seems to be a domain of x and y. That's very, very evident, and that will satisfy this relationship x minus y is equal to mod x minus mod y. So what happens for the second case when x is greater than equal to 0 but y is less than 0? So our left hand side is still x minus y, but the right hand side, mod of x is x because x is greater than equal to 0, but mod of y now becomes minus y because y is less than 0. And so we end up with this x minus y is equal to x minus, and then within parenthesis we have minus y because modulus of y is now minus y being negative. So if we treat this like an equation, we basically get x minus y equal to x plus y. X cancels out from both sides, and if we take the minus y to the other side to join the plus y, we basically have y plus y, or 2y equal to 0, which means that y is equal to 0. Now remember, that was not the way we have defined the domain of y, because y was supposed to be a negative number less than 0. So this is clearly something that's contradictory, and seems like the domain that's given in option 2, it cannot be a possible domain of x and y if they have to satisfy this relationship x minus y is equal to mod x minus mod y. Now let's look at the third option, the third domain, x less than 0 and y greater than equal to 0. Again, the left hand side remains the same, x minus y, but on the right hand side, this time mod x becomes equal to minus x because x is negative. But mod y is simply y, because y is greater than or equal to 0. Just keep the definitions of the absolute value function, or the mod operation, and it will be easy to obtain these kind of relationships that we are seeing here. And then if we again solve this equation, we basically have minus y cancelling out from both sides, and we are left with 2x equal to 0, which implies x equal to 0. And again, this contradicts our initial assumption of the domain, which basically assumed that x is less than 0. But we're arriving at x equal to 0, which is not permissible according to the domain definition based on which this relationship is based. So clearly this is also contradictory, and this cannot be a possible domain for x and y for this relationship to be holding true. So far we have found that the options given in 2 and 3 don't work out as potential domains for x and y. What about the option 4? Because we have this, you have to select the appropriate combination of domains that cannot be true from A through E. And of course, there's option B, which states domain 2 and 3. But then in option E, we have domain 2, 3, and 4, which are which are listed as domains that may not be possible for x and y. So we have got to evaluate the domain given in option 4, just to help see what happens when both x is less than 0 and y is less than 0. In this case, again, the left hand side remains the same, x minus y, but on the right hand side, mod x becomes minus x because x is negative, and mod y also becomes minus y because y is negative. So we have the equation x minus y equal to minus x minus, and within parentheses, minus y. And then if we simplify this, we basically have x minus y is equal to minus x plus y. And then if we take all the x's on one side and all the y's on one side, we end up with 2x equal to 2y, which implies x equal to y. So here in this particular domain, it seems like there are values of x and y for which this relationship x minus y equal to mod x minus mod y will be satisfied. And that relationship, and those values are basically the criteria there is x has to be equal to y. And this is very evident if you look at both sides of the equation. For x equal to y, x minus y becomes 0, and of course mod x minus mod y also becomes 0. So if x is in this particular domain where x is less than 0 and y is less than 0, so there are a set of values in this domain which actually, for which this relationship x minus y equal to mod x minus mod y is satisfied, and those values, they are essentially equal values. For example, if we take x as minus 3 and y as minus 3, that will satisfy this relationship. Of course, not all values of x and y in this particular domain in option 4 are going to satisfy the relationship x minus y equal to mod x minus mod y. But there is at least a set of values, namely values for which x equal to y, for which this particular domain would still work as permissible for the relationship x minus y equal to mod x minus mod y to hold true. So we conclude that, well, domain 4 looks like a possibility, right? But only for a special set of values. Not all values in this domain will satisfy, right? But there can be values in this domain of x and y which will satisfy the given relationship x minus y equal to mod x minus mod y. So based on all of these findings, our conclusion is that this relationship 2 and 3, the option B, that cannot be true, meaning that no values of x and y in the domains that are given in 2 and 3 will satisfy the relationship x minus y equal to mod x minus mod y. For domain given in option 4, there could be values for for which this relationship can be satisfied and which is x equal to y. And for the domain given in option 1, pretty much for all values of x and y in that domain, this relationship x minus y equal to mod x minus mod y will be satisfied. So based on this, the correct choice is option B, 2 and 3.